Chapter 6, Section 3, Proving Quadrilaterals are Parallelograms. Some theorems that are going to follow closely the theorems that we talked about in the last section say that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is parallel. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is parallel. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. This first example says that we are given that triangle PQT is congruent to triangle RST, and they're asking us to prove that PQRS is a parallelogram. The first thing we need to start with is our givens. Remember that in a parallelogram, just based on the picture that we're given, PR and QS would be the diagonals of the parallelogram, if it is a parallelogram. Remember that the diagonals of a parallelogram bisect each other or cut each other into two congruent parts. So if we look at triangle PQT and triangle RST, notice that those two triangles have sides that are parts of the bisectors. If those two triangles are congruent, remember that corresponding parts of congruent triangles are also congruent. So if PQT is congruent to RST, then we can say that PT is congruent to RT and that ST is congruent to TQ because of the fact that corresponding parts of congruent triangles are congruent. Notice PT and RT are two parts of one bisector, and ST and TQ are two parts of the other bisector. Because those two parts are congruent, that means that the two diagonals are bisecting each other. So let's write that down in our proof. If PT and RT are congruent, they're also equal, and same thing with ST and TQ. That's just the definition of congruence. Because these two things are equal, we can say that PR and QS bisect each other because of the definition of a bisector. If you remember, a bisector cuts the other thing into two equal parts. Because PR and QS bisect each other, and PR and QS are the diagonals of this quadrilateral, we can say that PQRS is a parallelogram because if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. This next example says a gate is braced as shown. How do you know that the opposite sides of the gate are congruent? Again, look and notice that they've given us the diagonals of the quadrilateral, and they've also told us that the diagonals are bisecting each other because the point where they meet is cutting both of the diagonals into two congruent parts. So how do we know that the opposite sides of the gate are congruent? If the opposite sides of the gate are congruent, that means that this would be a parallelogram. Because the diagonals are bisecting each other, we do know that it is a parallelogram. So I wrote the diagonals bisect each other, so the gate is a parallelogram. The opposite sides of a parallelogram are congruent. This next proof is it's a long proof. It's actually going to take two different slides, so kind of stick with me. They tell us that HJKM is a parallelogram. So the larger shape here is a parallelogram. They also tell us that triangle IJK is congruent to triangle LMH. They're asking us to prove that HIKL is a parallelogram. HIKL would be the smaller parallelogram that's kind of cutting through the larger parallelogram on the screen. So just like always, we're going to start with our givens. Rewrite what you're given, and the reason is that you are given. If we use what we are given, and just like most proofs, there are several different ways that you could do this. This is just one example. If you use what you're given, you can say that HJ is parallel to MK and that HJ is equal to MK. Because remember, the definition of a parallelogram says that opposite sides are congruent and parallel. Using this fact, we can also say that IJ is equal to ML because corresponding parts of congruent triangles are congruent. Next, I can say that HI plus IJ equals HJ, and we can say that ML plus LK equals MK, and that would just be the segment addition postulate. Because I know that HJ and MK are equal, I can go ahead and I can substitute in HJ for MK by the substitution property of equality. So I can say that ML plus LK equals HJ. I'm going to go to the next slide to finish this proof. My next statement can be that HI plus IJ equals ML plus KL because of the transitive property of equality. I can also go ahead and I could substitute in, I could say HI plus IJ is equal to KL plus IJ because I substituted in IJ for ML, because earlier in our proof we had said that ML is equal to IJ. The next thing that I can say is HI is congruent to KL because of the subtraction property of equality. All I've done is I've taken out IJ and from both sides. So if I have HI and KL are congruent, are equal, then I can say that HI KL is a parallelogram because if one pair of opposite sides of a quadrilateral are congruent and parallel, then it is a parallelogram. So I've proven that HI is congruent to KL, and I've also proven that HI is parallel to KL because it is a segment that it is on a segment that is parallel to each other. The next example says to show that A at -1, 2, B at 3, 2, C at 1, -2, and D at -3, -2 are vertices of a parallelogram. The first thing that we need to do when we're given this information is go ahead and graph it on a coordinate plane. Go ahead and connect your points. We have several different ways to show that a quadrilateral is a parallelogram. Based on this picture, I thought, and there's definitely not one correct answer here, there's about 5 different ways that you could do this. I thought that the easiest way, because I do have the two sides on the top and the bottom, they're very nice to measure or find the distance of. They're also very nice to find the slope of. So remember that if one set of opposite sides are congruent and parallel, then I can prove that it is a parallelogram. So I went ahead and I chose the top and the bottom sides, and I said both of these opposite sides have a length of 4, because I can just count the units because they are horizontal lines, and a slope of 0, again because they are horizontal lines. So one set of opposite sides are congruent and parallel. Because one set of opposite sides are congruent and parallel, I can say that this shape is a parallelogram. Today's assignment is on page 342. It's numbers 9 through 14, 17 through 20, and 25 and 26.